going to talk about polygon law of vector addition. So we talked about triangle law and parallelogram law of vector addition, which were used when we had two vectors and we had to add them by using vector addition. So now we are going to talk about when we have multiple vectors. So it can be 2, 3, 4, 5, any number of them, and how we can find the resultant in that case. So polygon law of vector addition. So let's first of all talk about the statement. So to write the statement, it states that it states that if a number of vectors, if a number of vectors acting simultaneously simultaneously at a point at a point mm, at a point so if a number of vectors acting simultaneously at a point are represented are represented are represented both in magnitude and direction both in magnitude and direction by the sides of by the sides of by the sides of a polygon of a polygon um, taken in taken in same order taken in same order then the closing side um, then the closing side then the closing side of the polygon taken in opposite order taken in opposite order represents represents the the resultant of all vectors of all vectors. So if you're like me, you did not understand anything by what I have written. So to understand this, we will have to look at some pictures and understand what we are talking about. Okay, to understand this, I'm gonna take a random number of vectors. Let's take 4. Of course, you can take any number from 2, 3, 4, 5, 6, and so on. So we are gonna take, let's say 4. So let's make some vectors. So let's make it over here. Let's make this one, and I will actually change the thickness of this to like this. Then let's move this. So let's make all of these vectors act on the same point. Um, so I'm just making random vectors, no thought about any of them, just making them as I want. Let's make them in random directions so that they look random. So let's move this one like that. So also let's color code them. Let's make this one white, this one let's say yellow, this one green, and this one blue. So we have these colors, and let's not name them right now, and we are saying that they act from this point. So think about a ball, and there are forces being acted from this direction, this direction, this direction, and this direction. So that's what I'm talking about. So they are acting from a point. And since we learned from what is it called, parallel transformation, we can move all of these vectors and it wouldn't change nothing. So before we do that, let's go back to our statement, which is if a number of vectors, so this is a number of vectors, in this case it is 4 vectors, but it can be any number, so except one, since one is already its resultant. So if you, let's say you only had this vector itself is resultant, since resultant is just like adding them to make it a single thing. So now a number of vectors, in this case we have four, um, acting simultaneously at a point. So they are acting simultaneously at a point, which is this point. So are represented both in magnitude and direction. So the magnitude, which will be the length, and the direction, which will be the direction of the arrow, um, by the sides of a polygon taken in same order. So we need to make a polygon. So before going to making a polygon, in this case it will be actually a pentagon. Let's see what is a polygon. So let's go a little bit off topic. I mean, it's in the topic, but it's a little bit off the topic. So what is a polygon? So to understand a polygon, the most basic definition that I found was polygon is a closed is a closed is a closed two-dimensional two-dimensional shape shape made of straight lines straight lines a straight line segment sorry straight line segments, joined joined end to end. So this is just the definition for definition's sake, but actually let's talk about the examples, which will make it much more clear. Example would be triangle, or it can be square, pentagon, square, pentagon. So I'm just taking random shapes, etc. So these are polygons. So if they can be made by straight line segments joined end to end, they will be. So let's actually take some shapes. I think there are shapes over here. So triangle is this thing. So this thing is a triangle. I think it is pretty clear to anyone. And after that, this thing is a square. It's supposed to have equal lengths. It might not be equal, but just think of it as equal. And a pentagon. Do I have a pentagon? Of course, I have a pentagon. So this is a pentagon. Of course, this can be rectangle as well. So square is not the only one. Triangle is not the only one. So there are multiple ways to make polygon. So you can actually see, so it's a closed, so there is no opening. So if a person was here, he can move around, but he cannot escape this place. If it was something like this, he could escape from these and this corner, but here there is no escape. So this is a closed thing, and it is two-dimensional shape, which means it is not represented in 3D. It can be drawn on a plane made of straight line segments. So straight line segments and joined end to end. So they are joined from end to end. So now let's go back. So we have this. Now let's make it into a polygon. So before we make it to the polygon, let's go back and read the statement once more. If a number of vectors, so we are taking 4 vectors in this case, acting simultaneously at a point are represented both in magnitude and direction by the sides of a polygon taken in same order, so we will make the polygon intersect. Then the closing side of the polygon is taken in opposite order, represents the resultant of all vectors. So we have to leave one side as open, and there is always gonna be one side open, or if there is no side open, it means that it is 0 vector. So we will talk about that. So before that, let's go here. So let's copy these, and so I'm just basically parallelly transforming them. So let's make a arrow, so that so when I parallelly transform this vector to this vector, so when I move it from here to here, this vector actually disappears. So this is like going here. So which means that we are not adding extra vectors. So that's not what we are doing. Now let's copy this one, and let's put that. So we are taking that in order. So this is what is taking in order means. So right over there, and this one right over here. So this is actually gonna be a pentagon, but it's not gonna be a regular pentagon. A regular pentagon is something like this, where all the sides are equal and all the angles are gonna be the same. Whereas right over here, it's gonna be a pentagon. So let's draw a line so that this is gonna be a pentagon. It's just that it's gonna be a very off-sided or very not cool, not beautiful let's say not beautiful, okay? Beautiful in terms of what I think is beautiful, not the definition. I don't know. But anyway, it's gonna be not a regular pentagon. So, but we can talk about what is gonna be. So we made a polygon and taken in same order, which means head. If you're walking, you're not changing the direction. So think of a man. He goes from here to here, here to here, here to go here, here to here. Since the arrow point in this forward direction, so he's not coming back in any of the cases. So now, also here, the closing side of the polygon taken in opposite order represents the resultant of all vectors. So the going in the opposite direction, so this has to be in opposite order. So a person going from here, 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 but it's not gonna go from here to here, but rather it's gonna go the opposite direction. So let's make it red, since I think in the other video we made red color. If you want to learn about other I think triangle law and polygon law, you can obviously check it out. I have made a video, and I think in the start of the video there would be a suggestion for the playlist as well. So this red one, this red vector represents all these vectors. So I don't think I actually explained what this resultant actually means. It means that all these vectors, so the white one, yellow one, green one, and blue one, if they were not here, so if they were here, so first of all, if they were here, so they were here, and you had to represent the thing. So think of, there was a ball over here, and you showed that there are these four forces, and if you had to show another figure where you had to show the same ball and only one force that would represent what would the outcome will be, it will be this red force. So it's not that we are adding another force, it's that all of these force is equal to this force. So the result will be equivalent, so you can't say it will be the same. So this is what we are talking about. So we talked about polygon, now we talked about statement. Now let's do some proof. Even though this proof is not like the foolproof proof, like it's very specialized case, but this works for every single pentagon, a pentagon, square, a triangle, or any polygon. So if we only had two vectors, so think about if I only had the yellow one or the let's say the white one, then it would just be triangle law, since it will form a triangle, that so it will form something like a triangle like this, and the last side will be in opposite order, which means it's just a triangle law. So this is how the polygon law relates to the triangle law, and we already know how the triangle law and parallelogram law work. So now actually let's talk about something else. So let's do some proofs. So let's consider four vectors. So let's name the vectors. Let's call them vector A, vector B, vector C, and vector D. So and vector D. So which represent okay, so which are represent would be better. So which are represented by the sides. So by the sides OP, PQ, QS, and ST. So of a closed polygon, OP, OPQ, STO. STO respectively, as shown in figure. So as shown in figure. So a question that you might have is, where is the figure? So we are just gonna convert this figure to that one. So we had A, B, C, D vectors. So let's call this A vector, this one B vector, this one C vector, and finally this one D vector. So even after parallelly transforming it, it's still gonna be the same vectors. So let's write the same vectors. This is B, this is A, and this is C. Okay, so we have this. So, and we also have to label the quadrilateral, oh sorry, the pentagon. So let's go back. It is OPQPQ, so it's OPQSTO, so OPQSTO, so OPQSTO. So I think this is the quadrilateral that we were talking about, and it is. So now we what we said, so what we considered, we created it. So now let's talk about what to do now. So according to Polygon law, according to Polygon law, the closing side, the closing side of the polygon, of the polygon, OT. So let's go back and see if it's OT. Yep, it is OT. So this is the closing side. OT represents the resultant. So let's say the resultant is vector R, then it will represent the sum of vector A, vector B, vector C, and vector D. So this is vector addition. So let's go back to the figure and let's add vector R over here. So now we did this. So, but how can we be sure that this is the result that we are gonna get? To understand this, let's look at the proof. So to do the proof, for the proof, let us join. So let us join point O with Q and S so that vector OQ must be equal to vector E, and so this is just my representation of E. You can also write this one. I write it in any way that I like, depending on my mood, so it's just a normal E unless I specify. So vector F, and let vector OS be equal to vector F. So let's go back right over here and just draw what we see. So join O with Q and S. So O with Q and O with S. Also, OQ vector will be vector E and OS vector will be F. So I don't think I have enough colors to represent all of them. That might be a problem. So let's see if I have all the colors. Let's do this purple. Let's also make this dotted, since this is something that we drew later. So this is drawing to OS. Let's make it orange. I hope this orange is not that difficult to understand. So this purple one, is vector E, and this orange one is vector F. So if you just look at OPQ, so this portion right over here, you might remember of some law, if you remember. So this law is triangle law, isn't it? Right? So this law is triangle law. So that's what we are going to do pretty much. So we are just going to use triangle law in all the cases. So now, using triangle law in triangle OPQ. So in triangle OPQ. So let me just copy triangle OPQ, which is this thing. So copy that, move it right over here, and let's copy the text involved with it as well, which is this portion. So copy that, move that down right over here. So this is triangle OPQ, and let's just use triangle law. If you remember triangle law, it states that two vectors that represent sides of a triangle taken in same order, then the resultant will be the um, other side, which is in opposite order. So I do not remember the exact statement, since I don't like remembering those stuff, but I remember the gist of it. So which means vector E, so this vector E must be vector A plus vector B. So this is, let's call this equation number 1. So this is from using triangle law in triangle OPQ. Now let's use triangle law. So using triangle law, using triangle law in triangle OQS. So you might be confused now, or you might not be confused. You might think, why are we using OQS? So let's copy that, let's move it, let's keep it over here, and let's copy the terms that are involved with the calculation, since I don't want to draw them again. So copy that, move that, let's copy this and move it over here. Yeah, I think that's fits pretty well. So if you look over here, if you forget the dotted lines, it looks like the triangle law once more, right? So that's why we are using the triangle law again. So if you use the triangle law again, this vector E and vector C are in order, whereas vector F is in opposite order, which means vector F must be vector E. So let's write it in vector E plus vector C, and this will be our equation 2. So now once we have this, let's I think it will be better to write in another page. So let's move this down so that it occupies more space. So let's go to another page. So we are again going to use the triangle law. So using triangle law in triangle OST. So let's go back. So it's, I think, over here, and we need OST. So OST. So that's the triangle we are going to take. So let's take this triangle, and also let's bring its letters, or the involved terms that we need. So that's the involved terms, I think. So now let's yep, that's it. So now let's use the triangle law. So vector F and vector D are in same order, so which means vector R must equal vector F plus vector D, and this is gonna be equation number 3, since we already used 2 and 1. So now let's use all of these equations. So now from equation 1, 2 and 3, so let's do, and let's make this a nicer 2, and let's make this a nicer 1. So from 1, 2 and 3, let's go back. We have vector R must equal vector F plus vector D, and we have vector F must equal vector E plus vector C, and we have vector E that must equal vector A plus vector B, which means we got our result that we needed, which is a good thing, I think. So vector A, vector B, vector C, and vector D. So boom, we got it, we proved it. So this is the proved. So this is the proof, and this is also a formula, as in a sense. So this is going to be a formula for a polygon type of things, but if there are other, there are obviously going to be more. So this is it for today's video. In the next video, we are going to talk about laws of vector addition, or properties of vector addition. Till then, bye bye.